Hello and good morning. This is video log entry, I think like, yeah, 125. And knowing me, I knew I was going to keep thinking about the structures I created. Structures, not really. I mean, I already had those structures in my mind, but I was just thinking a lot and sort of thinking, because I also was not really thinking about like the ramifications of like the indecisive nature of reality and all that, because I just didn't really feel like I was going to start thinking about it, but then I was like, I don't know, I should probably keep that for later and just have that in the back of my mind for a little bit. And the indecisive nature of reality, manifested through quantum physics, as you can see. And I was thinking, it's like maybe, like the truth, quote unquote truth, has to be completely aligned information. Reality doesn't, for some reason, tends to not have purely aligned information, just due to the fact that, I mean, you can see it everywhere, like the quantum nature of particles and whatnot, and it's indecision to have a place until, I mean, of course, you have like a particular range, or like, you think of the Schrodinger equation, and when you take the square of the wave, you have a probability distribution of where it's most likely to be, but it also collapses into one possibility when an observer perceives it. And I was just trying to see, like, why does perception make reality? Why does perception make reality make a decision, for what it should be at that given point in time and whatnot? And I don't know. That was really messing with my head a little bit, but it's all interesting stuff. And I don't really have a definite answer for that. I don't think does anybody really know, like, how of a good explanation of why reality tends to, I mean, of course you can think of like pure information and chaos and whatnot, so maybe it's kind of like a compromise point in reality. Is like it's somewhere in between, where there's some structure but not complete structure. It's like, so maybe reality, even if you have a particle, right, we still see it as a particle, but even within the particle, the definite information of the being is not necessarily completely precise. You could think of a lot of hidden variables that manifest as that particular information. It could be a whole conglomerate of other variables, or a whole superposition of other fields that create that one given field. Because we do, quantum physicists like to talk about superposition of fields and waves. Well, they say waves, but fields and whatnot. So those do occur because, the reason for that is because, of course, you have multiple beings affecting the quote-unquote quantum fields and all that. So just interesting to see. Very interesting to see. And I could keep thinking about it and whatnot, but I guess you could also just think of it as just I don't know. I really don't even know enough about the standard model to really say anything that's relatively educated and actually create some kind of underpinning that can connect to spirituality, and why it tends to do that, and being able to create a more abstracted structure that. Because what I was doing with the other video was, I was using classical field theory, which is okay, and using vectors is okay too. It works out because it works out with what I was doing. I made a few assumptions, like the vector is also happens. I made the assumption that these truth vectors are something that we can actually quantify, right? Something that we can actually quantify. You'd have to have like completely precise instrumentation for that, and we don't. So is it possible for us to do that with our minds and our limited physical creatures? But it's still fun to kind of think about it and whatnot, and it's still fun to think about it at times, and why certain stuff occurs and all that. Yeah. I mean, another thing is like I didn't really get into a lot of complex. I mean, I think I gave enough information. Like, wait, I didn't. I also, when you think of fields, you had to think about waves as well, and because these fields have like some attractor. It's like you can think of it as a uniform wave, but the wave always wants to go back to its quote unquote equilibrium, so there's an attractor going back. So that's why you have wobbling waves and particles and whatnot, right? That's why electrons tend to manifest as that, because there's some kind of disturbance in that field. Like, let's say you decide to poke you can also think of it as like you can think of it like space-time and like plopping a planet out there and deciding to just make it disappear, and then it creates a ripple effect. Basically, it's a wave. It's a wave. I don't feel like having to rederive that. I mean, it's you can also, I think they have a lot of models. The main model that most people like thinking about is like a 2-particle model, or is it a 3-particle? Where you have one in the center, and then 2 others. I think so, because if you think of it like that, the center one is the equilibrium point, and then the 2 are the energy transferences until it becomes equilibrium again, and it'll stop after a while. The reason why it stops eventually is because that energy that is equated from, you could probably use Hooke's law actually, you could use Hooke's law like a spring. You can think of it as a spring, and stretching it out towards equilibrium is going to be a force associated with the K value of that. I forgot, there's like a K, and then like you could F is equal to some value times K. I forgot what the actual constants are, but some linear constants, linear. And the further and further it goes from that equilibrium point, the more force, energy, you can actually equate force to energy in that aspect, because, energy is work, so you can think of work, which is F times the ds, F dot ds. Just a difference, F dot ds. And that's basically how you equate. That's how you find energy and force, and then those can be translated into waves, and those waves are obviously energy, so of course via conservation of energy or information, that energy and information sent out to the other realms, quote unquote realms, and then eventually loses all, it becomes an equilibrium point again. So that's why stuff like that happens. I don't know where I was going with that, which is kind of explaining from a physical standpoint. And field theory is interesting. Field theory is can be used in a lot of places. You see it everywhere now. We're all trying to implement fields into basically all of reality. And I know a lot of people. There's like this guy named Chris Langan who developed the cognitive theoretic model of the quote-unquote universe, and he's trying to create I forgot what he was trying to create, like a linguistic format of some sorts that can explain basically every single possible theory of everything. So that's beyond my pay grade, and he's a very smart guy, and he's been focusing on that for probably more than 20 or 30 years, so he knows a lot more about that stuff than I do. Yeah. So, I mean, like, I was kind of, like, I was abstracting a lot of things, but, you can also, again, these are just truth vectors happen to be associated with energy and information, so that's all just information, or I guess when you think about waves, as opposed, these waves have, obviously, information. They have an amplitude and a frequency, and you can start equating it to that, because there's, like, a phase space of time. We have to use a phase space of time to get frequency anyways, so of course I know that's a human construct, but it works well in this realm. It works well in this realm. I don't know how else to say it. Yeah, it's really cool. Well, I mean, like, you beings also are like a manifestation of the phase space of time as well. Okay, I guess you can pause time and say that's also a being too, but it's just like in this world, energy has to be equated through time. It seems. It doesn't have to be, I guess. I mean, if you translate to information and whatnot, I guess that was also like a pitfall for physicists, is that you don't really have to use time to equate energy, right? Because, like, I mean, okay, fine. Like, when you first started thinking about like how physicists started thinking about energy and whatnot, it was through looking at potential energy, and that involves the time domain because sorry, I meant to say mechanical energy. Mechanical energy is a combination of its current energy that it has and the energy the potential energy, basically, of like how much energy it. You can think of being like kind of stuck in time. That's, with no movement or anything like that. But like it wasn't. It took him a while to figure out that energy isn't just that, and it took, I think, until Einstein to realize that energy is information, just via equals mc squared and all that. So the equation states that, basically. So like that was like looking at how the concept of energy kind of evolved through time is kind of cool too, and it's cool. I guess it was, yeah. I don't know. I really don't know of a really good way to say this, but like and I really don't know of an amazing way of like how quantum field theory can actually manifest through the concept of duality, and I don't know, like it's kind of like wonky thinking about like Schrodinger's equation for all of these other electrons and whatnot. I mean, again, these electrons are just disturbances of a field at different frequencies and whatnot. These charges obviously have a particular energy, and these energies are just, I guess are they called standing waves? I think those are called standing waves. And those standing waves transmit information to other waves, and basically just saying that, hey, I exist. So if there's like its complement, the world is that's how they transmit information to each other from a quantum field theory point of view, I guess, is through waves. And of course, these standing waves, and assuming that the energy doesn't deplete, which it does because it's transmitting information. Well, now that I think of it, I wasn't really thinking of it as right as I would, because in these this is in a vacuum as well, because when you think about like springs, when you think of like standard spring models, these they have a certain amount of tension, and these there are two factors affecting the dampening effect of the spring model. Is one, it's the air, of course, and then I believe it's a spring, because springs aren't perfectly. They take that energy and transmit into heat into its external environment. So there are two factors affecting it. It's the heat that is being transmitted into the spring to then radiate out into the atmosphere, and then there's just the actual atmosphere affecting it, which is why there's a dampening effect. But in quantum field theory, these electrons, once they exist, they stay there because there's in a vacuum. So there is still a attractor for that, which creates a standing wave. And there's disturbance, and so I mean, yeah, I mean, these are, again, this is all it kind of, you can still use truth vectors to a degree, because these truth vectors, especially in this field, they especially in this simple example of a electron and proton interacting with each other, you can just say this is, well, in this field, this certain amount of energy exists, or quantity, one-dimensional quantity, and you could still use it, and it would work out, because eventually there's going to be a complementary proponent that'll eventually blip into reality, and but again, like, this is via non-duality. Nature constantly wants to harmonize, so its objective function, nature's objective function is to harmonize. So of course, this is God, obviously, so God is like, oh, well, there's this here, I have to find a way to bring them together and come into harmony again. But again, another thing about harmony is that, I was thinking about this, harmony also tends to, from the external perspective, it's considered to be zero information, because I was thinking about like the complement of these particles, kind of, once they become one, you can think of like particles and antiparticles just coming in and coming out of existence, and well, actually, okay, maybe I can't say that, because neutrons exist. I can't really say that. because these neutrons exist and we still see them, and they also affect well, they're unaffected by other like they're there and they have some kind of information, but they're unaffected by any kind of attractor, I guess. So these neutrons, I don't know. My knowledge of physics is kind of hazy, and I mean that also just kind of states that there's more than just the attractors between protons and electrons and whatnot, and there's it's interesting. I have to think about that one a little bit more. I don't know. It's interesting because I wasn't thinking about that earlier. I was not thinking about that earlier. That's gonna mess with my head because it doesn't apply with what I originally thought about certain things. I mean, I guess you could say that it's in its own field, and also it still interacts with the Higgs field and all that, because it has a mass, and a mass is obviously a quantity that we use, and which can also be applied to. It's still a field effect. And again, like fields are just, all in all, fields are just ways to quantify information and whatnot. And we have these fields that it's just data. It's just data. It's information. But like, I don't know how. The only way that you can leave like neutrons is through having a sufficient amount of antiparticles that can actually quote unquote harmonize with it. Because of again, nature's need to harmonize with a particular set of information and whatnot. And I say sets of information, that's basically just being. But yeah, so I mean that's all cool. I don't know. I just felt like talking about that. Now, I wouldn't be able to explain precisely why. Okay, the only good explanation of why I could think of like the Schrodinger's wave equation and its need to quote unquote collapse and stay in one place in space and time. What is it? What was I saying? My only good decent explanation as of now is that it's just a way of nature's need to compromise between pure information and pure chaos, which is why you have these probabilities and whatnot. I think there's also another way of explaining that via what's his name? What's that guy's name? I don't know. I remember seeing it in one of my quantum physics books. What's his name? I can't remember. Oh, Bell's inequality. I think you can actually say something about that via Bell's inequality, because I remember it's just a way of, again, it's a compromise between chaos and information. Once you gain information in one place, you tend to lose information in others. So if you know a lot about it's like, because there's amplitude and frequency. If you know a lot about its frequency, it's harder to find the amplitude for some reason. And it was derived by some guy named Bell, I think. It's like a less than or equal to sign with, I believe it's Planck's constant over some number and some other number. Yeah, my memory's so hazy, I forgot what that equation was. But yeah, Bell's inequality. Via Bell's inequality, you can if you're focused on its energy, which is its frequency, then it'll be harder to find its actual place in time. I mean that kind of like makes sense with brains as well, because it seems like it's an example of perception to some degree. We're looking at like our brains, and even reality in general is all perception and all that. And I mean, if it's going to be perceiving one thing, it can only how can it perceive the other? I guess would be a way of saying it. Not really. I don't know. Yeah. Yeah. Perception. I don't know. Can somebody explain this to me? I'm gonna be bothered by this for the next couple of days. I knew this fucking shit was gonna happen. Hmm. Mm-hmm. Also, I guess you can maybe apply harmonization with it, because for you to harmonize with something, especially if it's your new mode of perception, reality likes to quote unquote focus on that quote unquote truth vector. If you change it, then the truth vector becomes that. So that's like where all of energy, nature's energy is focused on, is that new truth vector, and that's how they harmonize with each other. So it tends to ignore everything else and become harmonized with that particular piece of information, or that being, or a lot of ways to see it. But that actually does seem like that would be an example, or actually a particular explanation behind Bell's inequality. Because you're focusing on the energy of a particle, but not necessarily where it's located. Does that kind of make sense? It's a form of. It's all basically, again, seemingly nature's need to harmonize. I don't know if anybody else will be able to explain better than me, but. Yeah. I mean, like, you can also kind of look at this. Also, kind of, maybe you can think of it like as a tunnel vision effect. People talk about Carl Jung's synchronicities, and seeing numbers, and particular numbers that you start thinking about tend to pop up more in your environment. People like to explain it as, well, your brain's just thinking about it more, so you're going to be looking at that, and obviously that means the tunnel vision effect tends to kind of lose focus on other particular data points, so it looks like it's happening more as opposed to less, and then you wouldn't be thinking about, like, I don't know, like the time's 9:05 now, you wouldn't be thinking about 9:05, or you wouldn't be seeing 9:05 more in reality, because you're so focused on that particular reality. That is also seen as a quote unquote harmonization effect to a degree, because that is your quote unquote internal truth, and via nature's need to quote unquote harmonize, it creates a new truth vector with that particular number outside of its reality, whether it's 11 or some other number or whatever. That truth vector is there. It exists already. It's just that you happen to have aligned with that truth vector at that point. So then you focus on that more. Again, this is more of a human psychology point of view of it, but it seems to work pretty well with translating it into quantum. I've been doing that a lot recently, kind of looking at the connections between psychology and, well, it's also the complex systems and all that. So. That could actually be a pretty good explanation of Bell's inequality, and why when nature focuses on one or other thing, it tends to tunnel vision, forget about everything else. I think it's a good example. That actually kind of explains, yeah. So like if quote unquote taking measurements. Also, quote unquote taking measurements is obviously a form of perception or observation. And observation also creates a collapse of the wave function. Again, harmonization. The collapse of the wave function occurs because you happen to be observing it, and your truth vector is aligned with that particular. Again, now that I think of it, these objects tend to have multiple truth vectors. Outside of time, of course. It's disharmonized with itself. It doesn't really know what it has to be until you look at it, and then it knows. and then it aligns with its truth vector with yours, and it becomes that particular pure information to that degree. Pure information. But yeah, nature's need to. It's interesting to think about. Nature's need to compromise between pure information and chaos. Structure, chaos. Interesting stuff. It's interesting. Very interesting. So I may think about. I think I may just let myself think for a little bit. I don't really have anything else to do. I haven't been writing notes. I guess I wrote a few notes here. I was just kind of like looking at the general implications of my brain that for some reason it was like when every single time I think about non-duality, I just can't help but think about field theory. It's just like that's like the instant connection I had. It's like the instant implication or whatever. Field theory versus you can use vector analysis in field theory because it's kind of in a space domain, right? And you can think of like the flow of information and all that, and the information can, is pointing in a particular direction, and you can call it, again, you can think of like ley lines, and then you can start applying things since you've encapsulated those concepts within a field theory perspective. You can start thinking about like path of least action and all that. Because also that is another thing that nature seems to do that I didn't really mention, is that via harmonization, I think you can think about least action, or the path of least action, or nature's need to input as much. It wants to be in harmonization with itself when it's in harmonization with the external world, or when it wants to get to that point. It tries to use as little energy as possible to get there, if that kind of makes sense. You can actually see this in light. Actually, you can when you refract light, it chooses the angle in which it goes through that requires the least amount of energy, basically. Or well, that one is the shortest path, I believe. Yeah, that one is the shortest path. But when you think about that, this is within a medium, and the shortest path tends to means that it'll be interacting with the medium less. So that means there's less transmission of energy. Of course, you can think of light interacting with all those particles, so that means there's some form of heat transmission. I think not really. I think that's not a good way. I mean, there's a scattering effect, and they do. Light does. The way it interacts with particles is a little bit interesting. My dad knows more about optics than I do, but he talked to me about optics because my brother was talking about like planar engineering. That he deals with a lot of optics in his job, and he looks at mu scattering. He doesn't use Rayleigh scattering because I believe Rayleigh scattering works off of the presumption of like big particles, I think, because light tends to interact with particles along its big particles that are like its wavelength, or smaller or whatever. Or is that how it works? I don't know. I don't feel like thinking about that right now, but yeah. So Rayleigh scattering tends to work with that kind of stuff, and the atmosphere tends to have, you have oxygen, nitrogen, methane, of course, O3. And you can think of it as like a billiard ball, I guess. I think that people like to think of it like that, and that tends to somehow work well with Rayleigh scattering for the most part. I think there are certain levels in the atmosphere that tend to have more particles that are too big to really simulate Rayleigh scattering well, or to really align with Rayleigh scattering's model. Rayleigh's model. That's why they have something called mu scattering. And if my dad saw this video, he'd probably laugh at me because I'm probably completely wrong. I don't know. When is Rayleigh scattering actually best? I'm asking the AI. where light is scattered by particles much smaller. Oh, yeah, much smaller than the wavelength of light, of course. Yeah. Because at that point, I know there's like an analogy to kind of explain that. Yeah, shorter wavelengths scatter more readily than longer wavelengths due to that, yeah. That's true, that's why the sky is blue, of course. Smaller wavelengths tend to interact with the atmosphere more and scatter, which is why it hits our eyes. Yeah, that's beyond my pay grade. I'm just here thinking about reality as opposed to very complex systems involving scattering. But yeah, I don't know. Rayleigh scattering is basically used when the light wave has a smaller wavelength than the particle that's interacting with. Because I think, well, I mean, when you think about like the wavelength being bigger, you can. I mean, like how I think of it as is I think of it as maybe a ship suspended in a really big torrential storm where the waves are huge and they're not really affected by that ship. That's the analogy I use. I've heard of it from one of my teachers before when we were talking about this kind of stuff, and it's a good way to think of it. But yeah, I was just what was I talking about other than why was I talking about Rayleigh scattering? Oh man. Oh yeah, because of the planet generator. I don't know why I was going over there, but I need to be more focused. And oh god, I'm so talkative today. I've been talkative for a while. I just can't stop thinking. Yeah. I was just talking about my line of logic. I mean, this is not really rigorous, and nobody would really take it seriously. But it seems to be a pretty good line of logic where. It's like when people think about like was it non-duality? Yeah, non-duality. You think about fields because, fields would be a good way to think of that. It's just a good way to explain it, I guess. My brain is like, my brain wants to likes to think about like when people talk about things. My brain wants to go to an abstraction that's able to explain all of it, I guess, from a quote unquote mechanical point of view. Which can be achieved. It's just it takes a little bit more effort. Yeah, it's kind of cool. I think in explaining. I was able to actually explain the quote unquote collapse of the wave function, so that's actually a good connection point to make. I haven't really thought about it as much as I thought, and through the eyes of psychology in our own minds, we can actually sort of explain it for what it is. I mean, sure, it's like you would have to come. The thing is, like, for it to be that point, that given theory to be more valid, you'd have to go through more simulations to actually prove it right then. That's what I did with vector analysis. I went through all the simulations for the law of attraction. Well, not all. It's obviously impossible to do that, but a good chunk of simulations in my mind to kind of say it's a law. I would even say it's a law just because I can't think of anything that defies it. And I guess like my explanation of Bell's theorem and all that too is like I think it's a pretty good explanation. I think it's a pretty it's a quote unquote tunnel visioning effect of nature because it wants to harmonize with itself. Same thing with the collapse of the wave function, quote unquote tunnel vision effect because of nature's need to harmonize with itself. Right? I think that looks pretty good. And you can go through a lot of examples of why that works out in all possible ways systematically. of course, why would you not think about it systematically? Why that actually is a valid explanation of why these things are occurring in reality. So, yeah, it's kind of cool. Oh, another thing I forgot to mention is, people would probably say, wait a second. So, like, when you think about the double slit experiment, doesn't it interact with multiple things in between it? Yes, it does. But the thing is, when it interacts and it's aligned with its truth, the truth factor is constantly changing. So that means that the truth factor may be aligned with a new object, and then a new one, and then a new one, until it hits the, for what we can see, is that the truth factor's phase of expansion, the truth factor's evolution to then hit that wall was I mean, you can also think of it as line integrals. Feynman talks about that, and that goes into quantum field theory a lot. And I actually, I think just the way my brain works, I think I could probably go back to quantum field theory and read a book on it, because I've quantum field theory actually requires a lot of group theory and Einstein notation. I don't like Einstein notation. It's annoying notation to read, but eventually you have to get used to it if you really want to go into the deep underpinnings and mathematical representations of quantum field theory. You have to understand that. I think group theory is easy. I've basically taken out the abstract algebra, so I don't really have trouble with that. I think the only thing I'd have trouble with is for a little bit of time is probably indices, but even then I think that would the reason why indices tend to show up a lot is obviously through all the summations that we use, and because there's a lot of linear algebra and whatnot. But I just don't like having to parse through that. I feel like there probably should be a better way to parse through those kinds of summations than what we have. The thing is, like with mathematicians, they tend to get a little bit not, I guess, lazy. Also, indoctrination tends to kind of work off of one path, right? It's like nobody really thinks about like ways in which we can like change like a computer. This is why I like computer science, because computer scientists think of it from that perspective. They think of it from like, hey, what's the best way in which we can make this readable for the person that is messing with this language? Physicists don't do that. They don't care. They'll use something from 300 years ago and just keep using it and say, yeah, this works. It's like, okay, whatever you say, bud. That's how you want to do it. So I got annoyed with that. I was like, oh fuck. That's why I also didn't. I got annoyed with some of my classes. Like for the love of God, why are we still using summation notation? There has to be another way to represent this more parsably. Like what the fuck? Who actually even who invented summation, or who invented summation notation? Who invented Euler? Freaking Euler! This dude from Euler's cool. He invented Euler's number. He's a genius and all that. But for the love of God, he invented summation notation in 1755. That's 270 years. 270, almost 300 years. Like, what the fuck, man? Jesus. I don't know. I get annoyed with those kinds of things. I know maybe I hope there's somebody out there that sympathizes with me when it comes to that kind of stuff. But whatever. At least I can create my own abstractions. Maybe other people won't be able to understand, but fuck them. I don't care. I'm gonna do things my own way, because apparently I'm too stubborn to go down the standard route for somebody like me. Yeah, I don't know. Also, like, okay, so I shouldn't be bashing summation notation as badly. I personally think computer scientists have found a more parsable way of dealing with summation notation. Although, I mean, like, I guess you can get your brain to make the connection that, summation notation is nothing more than permutation. you could just think of it like as possible permutations, like you have double summation. If you have one summation notation, it's just like, it's going through a list basically, and if you have two, then it's still going through a list, but you have two lists at this point, but then you also have to look at it's basically just looking at all possible permutations of those things and whatnot. It's not complex, but it's still annoying to deal with at times, and I don't know. Maybe I just don't like the symbol. Okay, the symbol is kind of cool. It makes us look badass. It's like, ooh, it's like a weird E. I don't know. Okay, the symbol's kind of cool. I like the symbol. Maybe that's the reason why mathematicians like doing that. They like their Greek notation and all, and whatever. I'm not complaining. Anyways, that was a somewhat productive video for my mind, at least. Maybe not for the world and this outside world, but it's good for my mind. I like. I see, but yay, via a non-duality, maybe my world will change again. Just kidding. That stupid joke. That was a boomer joke right there. That was even worse than a boomer. I don't even know what that was. Anyways, bye.